particularly the galvanic or voltaic cells in which a spontaneous chemical reaction is bringing about electrical energy. Here was also trying to discuss with you how these galvanic or voltaic cells are built. How they are built, I've told you. If there is a spontaneous chemical reaction happening naturally, what would happen is that it will be an exothermic reaction generally, and what would happen is there is a lot of liberation of heat energy. Now, they want to construct the apparatus in such a way that there should be net electrical energy that has to be in it. Okay, so how to tap electrical energy, how to get electrical energy from a chemical reaction instead of heat energy? How? Then I've told you the cell construction. Okay, they have understood what is very important is that for the current to flow, first point is that we need to create an EMF. Okay, so how they have created EMF? By taking again anode and cathode. Okay, so how EMF would be created? By creating an anode and a cathode. And we know that anode is an oxidation electrode and cathode is the reduction electrode. Okay, so the electrons would be flowing from anode to cathode. Okay, how much will be the EMF of the battery? The potential difference between the two ends. Okay, now roll number 85. Good morning.
Good
Are you
morning,
there?
ma'am.
Yeah. Yeah, tell me, did I give you the definition of EMF?
You gave definition of potential difference EMF.
Enter what it is.
Driving force
What
for
is
flow
EMF?
of charge, ma'am.
Driving force for flow of charge. That means the 2 points between which the electrons are moving or the ions are moving are at two different gradients. Okay, so that's how I'm creating EMF. So again, in this case also I have created EMF. How? By creating one anode and cathode. And the flow of ions in galvanic or voltaic cells would be from anode to cathode. Okay, that part we understood. Also we understood that how the electrodes are built. Now tell me, roll number 85, how the electrodes are constructed in galvanic or voltaic cells.
Ma'am, in galvanic or voltaic cells,
Electrodes ని ఎలా బిల్డ్ చేస్తాను? ఎలా ఎలా చేశారని చెప్పాను? రెండు
electrodes are
మెటల్స్
externally connected, ma'am, with flow of
కాదు,
electrons.
ఎలక్ట్రోడ్స్ ఆర్ బిల్డ్. నీకు క్లారిటీ వచ్చిందా లేదా? నేను ఏం క్వశ్చన్ అడుగుతున్నానని. The others also you can answer. How electrodes are constructed in galvanic or voltaic cells?
Anode and cathode are constructed by dipping a metal rod in its own metal ion solution.
Why? Okay. Okay, roll number 85. మీ పేరేంటి? Boy,
Yes,
what's
ma'am.
your name?
Karthik.
Karthik. Okay, Karthik. Uh, so, so how electrodes are constructed in galvanic or voltaic cells? Can you answer me now?
They are constructed by taking down a metal drawn in its own metalloid solution.
Why? Did I explain why? No. But how they are connected? How the two electrodes are connected?
Externally,
Externally by
wires,
wires. Internally by
salt
internally
bridge.
by
with the help of salt bridge.
Good. Very good. So that's what I expected. So that's the construction of an electrochemical cell. Now, why the electrodes are constructed like this is what we are going to learn right now, and also learn few important definitions for the purpose. Okay, fine. But the point here is, why all this? Why the construction like this? What would happen if I'm just connecting two metal rods externally? Does it produce anything? No. Okay. So because I'm talking about electrolytic conductance, I am talking about electrolytes, okay, which are actually participating in the chemical reaction for generating electricity. Okay. Now roll number 86. Now what type of reactions are they? Good morning. Roll number 86. Are you there? Roll number 86 is present. Okay. So roll number 86 is absent. Fine. Now 87.
Yes, ma'am.
Okay. Good morning. Now tell me, you understood the question? What type of chemical reaction takes place? You tell me.
Redox reactions.
Redox reactions will take place. What reaction would take place at anode?
Oxidation.
Loss of electrons or gain of electrons?
Loss of electrons.
What reaction would take place at cathode?
Reduction. Gain of electrons.
Huh?
Reduction, ma'am.
Reduction reaction. What is electron change? Gain or loss? Gain of electrons. Okay. Now what it means by cell reaction? Hmm?
Don't know, ma'am. Half cell reaction.
Oh my God, what is this? What it means by cell reaction?
Redox reaction, ma'am.
It's a redox reaction or the overall reaction that is happening. Okay. And what each electrodes are called?
Half cells.
Good. And the reactions are called?
Electrode reactions.
Yeah.
Half cell reactions.
Electrode half cell reactions. Good. So you have got clarity. Now why all this cell construction? Now when you're going out, okay, and you're buying one battery, after getting it home, what you would check? When you're getting a battery home,
Whether the battery is working or not.
ఇంకా ఓ బ్యాటరీ కొనేటప్పుడు నువ్వు
Voltage.
ఏనా
Voltage, ma'am.
వోల్టేజ్ కరెక్ట్ ఎన్ని వోల్ట్స్ బ్యాటరీ దట్ ఈస్ ఇంపార్టెంట్ and the size of the battery. Am I correct? See, there are bigger batteries and there are smaller batteries. There are small button batteries and all. Various types of fabrication of batteries are now found. Is it not? So what we'll check whether the battery I'm buying is a rechargeable battery or not, or what is its EMF. Okay. So when I'm uttering that word EMF, what is the idea behind? It's the potential difference between anode and cathode. As simple as that, anything. Okay. So I'll again boil down to the same discussion. Means I'll check with the anode and cathode. Okay. What is the potential of anode? What is the potential of cathode? And what is the potential difference between the two, which is making the electrons move from anode to cathode, is what exactly I'm planning while constructing a galvanic or voltaic cell. Okay. And the discussion begins. Okay. Here, why the construction of any electrode, whether it is anode or cathode, is dipping the metal in its own metal ion solution. Why? Is because there is a potential difference between any two ions, whether it is same metal or different metals. Okay, so the potential difference between any two oxidation states of the same metal or different metals can be exploited for the creation of potential. Okay, it's as easy as that. అంటే ఏంటి చెప్పండి. ఎంత సింపుల్ అంటే నువ్వు కాపర్ వైర్ మామూలుగా ముట్టుకుంటే ఏమీ కాదు, అదే నువ్వు ప్లగ్ ఇన్ చేసిన కాపర్ వైర్ ని ముట్టుకోగలవా? షాక్ కొడుతుంది. ఎంత షాక్ అంటే ఇంక మనం తేరుకోలేం. అంటే ఏంటి, ఏమవుతుంది, ఎప్పుడైతే మీరు కాపర్ మెటల్ యాజ్ సచ్ వైర్ ఉన్నప్పుడు ముట్టుకుంటే నో పవర్ ఫ్లో, సో నో ప్రాబ్లం. But as soon as you are plugging in, what you are doing, you are creating an EMF, which is making the flow of electrons. Okay, so flow of electrons అవ్వటానికి అంటే ఏముండాలి, టూ పొటెన్షియల్ పాయింట్స్ ఉండాలి, అంతే. సో ఇక్కడ కూడా ఏం చేశాను, ఎలక్ట్రోడ్స్ నేను ఎలా బిల్డ్ చేశాను, ఐ హావ్ టేకెన్ ఎ మెటల్ and for ease I have dipped it in its own metal ion solution. Okay, and there exists a potential difference between the pure metal and its metal ion solution. Why? In the metal ion solution, the metal is in some oxidation state, +1, +2, like
Voice
that.
breaking, ma'am.
Okay, the metal would be in some oxidation state when it is in its own metal ion solution. Am I right? You understood what I said? Okay, that means what is the oxidation state of metal in pure oxidation state, in its native metallic form? Pure
Zero.
copper metal తీసుకుంటే zero, pure aluminum తీసుకుంటే zero. As soon as you take its metal ion solution, it means that the same metal is existing in different oxidation state, and there is a difference between the metal and its own metal ion. The difference in its energy is called as electrode potential. Okay, so what is electrode potential? Defined as the potential difference between the metal dipped in its own metal ion solution is nothing but single electrode potential. Okay, now that's the first point. Or single electrode potential can also be defined as the tendency of a metal to lose or gain electrons when it is dipped in its own metal ion solution. Okay, is what is called as single electrode potential. Now, why I need to know about single electrode potentials? Okay, in yesterday's class, I was trying to tell you that in Daniell cell, there is zinc which is acting as anode, and there is copper acting as cathode, and the potential difference between zinc and copper is creating the electricity, and hence can be used as an electrochemical cell or a galvanic or voltaic cell, because I already know it. Okay, but how to say this metal is an anode, this combination is an anode, this combination is a cathode, or how the combinations can be made, how to do it? It's very easy. By first taking single electrode potentials of various metals. What they have done the experiment and they brought in the conclusion. That means they observed everything from the experiment and they made a conclusion that when a metal is dipped in its own metal ion solution, they show a tendency either to lose electrons or gain electrons. Okay, and it is naturally studied. Okay, the metals which show the tendency to lose electrons are undergoing oxidation and hence give oxidation potentials. Okay, there are certain metals which show the tendency to gain electrons. Okay, and hence will show a tendency of gaining electrons, undergoing reduction, and they give reduction potentials. These are studied experimentally. And what they have done, they formed a series called as electrochemical series or EMF series by measuring the single electrode potentials of various metals and non-metals against a standard electrode called as hydrogen gas electrode. Okay, and hence is the EMF series. When you once look into this EMF series, what you will understand? You'll understand whether a particular metal shows a tendency to act as anode or cathode. Okay, that means whether it is showing a tendency to lose electrons or gain electrons, and hence is the series all about. How to find this electrode potentials? You have dipped a metal rod in its own metal ion solution, and there exists a potential difference between zero oxidation state and the oxidation state of the metal in the solution. Okay, both are different. How to measure them? They have measured taking an electrode called as hydrogen gas electrode, whose single electrode potential they've arbitrarily assigned as 0. Okay, and hence that electrode is called as standard reference electrode. Okay, and hence they found all the electrode potentials of various metals and non-metals and put into a chart called as EMF series or electrochemical series, which helps us to understand what is the single electrode potential of each of the metal or non-metal and how it is acting, whether it is acting as anode or cathode with reference to the other metal to which it is attached. Okay, and hence this is a very important definition you need to know. Okay, ఏం చెప్పాను? సింగిల్ ఎలక్ట్రోడ్ పొటెన్షియల్స్ గురించి చెప్తున్నా. సరే, ఎలక్ట్రోకెమికల్ సెల్స్ కన్స్ట్రక్ట్ చేసినప్పుడు యానోడ్ ని క్యాథోడ్ ని ఎలా కన్స్ట్రక్ట్ చేస్తున్నారు? ఒక మెటల్ రాడ్ ని దాని ఓన్ మెటల్ అయాన్ సొల్యూషన్ లో డిప్ చేసి అలా ఎలక్ట్రోడ్స్ ని రెండింటిని బిల్డ్ చేసి కనెక్ట్ చేసి ఈఎంఎఫ్ ని జనరేట్ చేస్తున్నారు. సరే, ఓకే, ఎలక్ట్రోడ్స్ ని బిల్డ్ చేస్తున్నాను, బాగుంది. కానీ ఏది యానోడ్ కింద యాక్ట్ చేస్తుంది, ఏది క్యాథోడ్ కింద యాక్ట్ చేస్తుంది? అసలు ఈ ఎలక్ట్రోడ్ ని ఎందుకు ఇలాగ మెటల్ ని ఒక మెటల్ అయాన్ సొల్యూషన్ లో డిప్ చేసి అసలు ఎందుకు ఇదంతా అంటే సింపుల్. ఎప్పుడైనా సరే ఒక మెటల్ ఎలక్ట్రాన్ ని లూజ్ చేసే టెండెన్సీ ఉందా, దానికి గెయిన్ చేసే టెండెన్సీ ఉందా అనేది ఎలా కనుక్కుంటారు అంటే సింగిల్ ఎలక్ట్రోడ్ పొటెన్షియల్స్ ద్వారా కనుక్కుంటారు. అంటే ఒక మెటల్ ని దాని ఓన్ మెటల్ అయాన్ సొల్యూషన్ లో డిప్ చేస్తే అన్ని మెటల్స్ ఒకటేలా బిహేవ్ చేయవు. కొన్ని ఏం చేస్తాయి, దే షో ఏ టెండెన్సీ టు అండర్గో ఆక్సిడేషన్, అంటే ఎలక్ట్రాన్స్ ని లూజ్ చేసుకుంటూ ఉంటాయి. ఓకే, అప్పుడు మెటల్ సొల్యూషన్ లోకి ఎంటర్ అవుతూ ఉంటుంది. కొన్ని మెటల్స్ ఎలా ఉంటాయంటే అవి ఎలక్ట్రాన్స్ లూజ్ చేసుకోవు, దే షో ఏ టెండెన్సీ టు గెయిన్ ఎలక్ట్రాన్, అండర్గో రిడక్షన్ అండ్ గెట్ డెపాజిటెడ్ ఆన్ ద ప్యూర్ మెటల్. ఓకే, సో ఈ టెండెన్సీ ఆఫ్ వేరియస్ మెటల్స్ వేర్ స్టడీడ్ ఎక్స్పెరిమెంటల్. ఓకే, ఎందుకు అంటే సింగిల్ ఎలక్ట్రోడ్ పొటెన్షియల్ అంటే ఏంటి? ద పొటెన్షియల్ డిఫరెన్స్ బిట్వీన్ ప్యూర్ మెటల్ అండ్ ఇట్స్ ఓన్ మెటల్ అయాన్. ఓకే, సో ఎప్పుడు జీరో ఆక్సిడేషన్ స్టేట్ నుంచి వేరే ఎనీ ఆక్సిడేషన్ స్టేట్ మధ్యలోకి మారితే మెటల్, ఆ రెండింటి మధ్య ఉన్న పొటెన్షియల్ డిఫరెన్స్ ని నేను సింగిల్ ఎలక్ట్రోడ్ పొటెన్షియల్ అంటున్నాను. ఓకే, ఆ సింగిల్ ఎలక్ట్రోడ్ పొటెన్షియల్ ఎలా ఉంటుంది అంటే ఇట్ కెన్ బి ప్లస్ ఆర్ ఇట్ కెన్ బి మైనస్. That means it might show the tendency to undergo oxidation or it might show the tendency to undergo reduction, and it is studied experimentally. Okay, that's how they kept on studying the behaviors of various metals dipped in their own metal ion solutions, and they got a series called as electrochemical series, in which they placed various metals and non-metals in the increasing order of their స్టాండర్డ్ రిడక్షన్ పొటెన్షియల్. అసలు ఇది ఎలా మెషర్ చేశారు అంటే ఏమో, ఒక మెటల్ యానోడ్ అవ్వచ్చు, ఒక మెటల్ క్యాథోడ్ అవ్వచ్చు, డిపెండింగ్ అపాన్ ద అదర్ మెటల్ విత్ విచ్ ఇట్ ఈస్ అటాచ్డ్. కరెక్ట్. సో ఈ సింగిల్ ఎలక్ట్రోడ్స్ పొటెన్షియల్ ఎలా మెషర్ చేశారు అంటే ఒక ఎలక్ట్రోడ్ ని తీసుకుని హూస్ ఎలక్ట్రోడ్ పొటెన్షియల్ ఇస్ ఆర్బిట్రర్లీ అసైన్డ్ యాజ్ 0. అదే హైడ్రోజన్ గ్యాస్ ఎలక్ట్రోడ్. Standard hydrogen gas electrode is one electrode whose electrode potential is arbitrarily assigned as 0, and they measured the electrode potentials of all other metals and non-metals combining with that standard hydrogen gas electrode, okay, and formed the EMF series. Okay, so that's the next important point you need to know. Any doubts? Raise your hand or write the definition. Put today's date and write. And write. Rule number 86 is absent. Okay. Single electrode potential. Single electrode potential. In brackets, capital E. Single electrode potential, capital E. Single electrode potential, in brackets, capital E. It is the tendency, of a metal dipped in its own metal ion solution. It is the tendency of a metal dipped in its own metal ion solution to lose or gain electrons. To lose or gain electrons. Or single electrode potential can also be defined as the potential difference between metal and its own metal ion, or two different oxidation states of the same metal, or two different oxidation states of the same metal. Therefore, E is equal to M slash Mn plus. Metal has underwent oxidation, metal ion. So, oxidation potential. Okay, you got it. Is it clear? If it is oxidation potential, metal is losing electrons and forming positively charged ions. Okay? Or if Mn plus is getting converted to M, it is nothing but reduction potential. Reduction potential. Oxidation potential or reduction potential. Okay. Now roll number 88. Good morning.
Good morning, ma'am.
Yeah. Now in yesterday's example of Daniel cell, okay, which underwent oxidation? Which underwent oxidation?
Zinc, ma'am.
Zinc. Good. So how can I write zinc as? Zinc oxidation potential. How to write? Okay. Zn
Zn slash
slash
Zn plus 2. 2 plus.
Antena? Zn slash
Zn
Zn
2 plus.
plus oxidation potential.
Potential.
Which underwent reduction?
Copper, ma'am.
Copper. So how can I write the reduction potential as Cu2 plus slash
Cu2 plus slash Cu.
Cu
Cu.
is the reduction potential. Correct?
Yes, ma'am.
Okay, good. Now, right. Next, you understood about single electrode potential. Now write the next definition. Standard single electrode potential. Standard single electrode potential. Standard single electrode potential. And it is given as E naught, capital E 0, E naught. Okay. So standard single electrode potential E naught. Okay. Right. The electrode potential is referred as standard electrode potential. The electrode potential is referred as standard electrode potential when the temperature is 25 degrees centigrade or 298 Kelvin. When the temperature is 25 degrees centigrade and or 298 Kelvin, and the concentration of the electrolyte is 1 molar. When the concentration of the electrolyte is 1 molar or 1 atmosphere when gases are considered. 1 atmosphere when gases are considered? When gases are considered. Okay. It is referred as standard electrode potential. Next point. I think this is point number 24. Point number 24. Okay. Right. What you are going to write? How single electrode potentials are measured? How single electrode potentials are measured? Answer: using standard hydrogen gas electrode. How single electrode potentials are measured? Using standard hydrogen gas electrode whose single electrode potential is arbitrarily taken as zero. Whose single electrode potential is arbitrarily taken as zero. Is arbitrarily taken as zero. Okay. Now have a small question. Roll number 88. Good morning. Are you there?
Yes, ma'am.
Chepamma. What's your name?
Sheikh Abdul Rahman, ma'am.
Rahman. Yeah. I have a
Yes, ma'am.
question to ask. Now, I'm talking about the electrode potential and standard electrode potential, single electrode and standard electrode potentials. Now, what might be the units of electrode potential? Raymond, you got what I'm saying?
Yes, yes, ma'am.
I'm asking for the units for electrode potentials. Roll number 62.
Mole in, ma'am.
Nana? Yeah? Please get back.
Volts, ma'am.
Volts. Okay. Is he right? Roll number 62. Prithvi? Good morning. Roll number 99. Roll number 99. Are you there?
Electrode.
Huh? Okay. Is Rahman correct? Is my question. How many would support? Raise your hands. Rahman told that the units are volts. Is he right or wrong? Right? Raise your hands. It is volts. Who else? Or the rest just waiting for the answer, or you need to answer me. That's what I'm saying. Raise your hands if you support him. Yes. Correct. Okay. Now, Rahman, tell me, why did you say it as volts? Is it guess or is it your, can you support your statement?
Ma'am, the
Then-
electrons, driving force of electrons, no, ma'am, it is.
Oh, no.
You said the
Correct.
units for driving force, sir.
These volts, correct. And you're here. Very good. You got it. Nice. I'm happy. Now I can proceed. It's very good, nice that many of you have raised the hands. See what we are finding. While finding the single electrode potential or standard single electrode potential, what we are finding the potential difference between metal and its own metal ion. We understood that both these two are at two different energy states. Okay, and hence there is always a potential difference between a metal, pure metal in zero oxidation state, and there is a potential difference between the metal ion in some other oxidation state. It could be like anything, like Ag, Ag plus, Zn / Zn plus 2. It could be anything. There exists any two different oxidation state of the same system are separated by energy difference, which we are measuring as the EMF or the electrode potential. What do you have to realize is that the electrode potential depends upon temperature, the concentration of ions, okay, but not with what counter ion with which they are aligned with. Okay, see, if I'm taking copper dipped in copper sulfate or CuCl2, in both the cases, the oxidation state of copper is +2. Is it not? Still, the electrode potential remains the same. It will not depend upon the counter ion with which it is associated, but it depends upon the pure metal and the metal ion in which it is dipped. But the single electrode potentials as such would depend upon the temperature, the concentration of the ions. And if I'm maintaining the temperature at 25 degrees centigrade and the concentration of the electrolyte at 1m concentration, then the electrode potentials are called as standard electrode potentials. And that's what exactly we'll measure while combining the metals dipped in their own metal ion solutions against the standard hydrogen electrode. I hope most of you would remember what is the construction of the standard hydrogen gas electrode. Okay, so how they have constructed the standard hydrogen gas electrode? They took a beaker, okay, and they poured an acid of 1m concentration. 1m concentration of HCl or 1m concentration of H2SO4. They took HCl or H2SO4 where the concentration of H plus ions is, H plus ion concentration is 1m. Okay. Then they built a glass structure, something like that. Okay. Which is actually has an opening at one end. Okay. Something like that. And they bubbled hydrogen gas through it, which is at 1 atmosphere pressure. Here, for the electrical contact, they took a platinum wire attached to a platinum thin film or thin plate, okay, which is inert electrode. It does not participate. It just allows the hydrogen gas to bubble through. Okay. Now what they did, they took its single, there exists of course electrode potential between the hydrogen gas and H plus ions. Kids, remember which is the electrode here in this construction, which is the electrode, which is the metal? Metal or non-metal? Hydrogen gas ikkada. Okay, not the platinum wire. Okay, hydrogen gas is the metal. Okay, and we are finding the electrode potential with respect to hydrogen gas dipped in 1m concentration of H plus ions, whose this construction has some electrode potential, but we made it as 0. So electrode potential of this electrode is 0. Okay. Now I kept on combining this electrode with other electrodes like zinc in zinc sulfate, copper in copper sulfate, silver in silver chloride or silver nitrate, like that. Every combination is tried. Huge experimental work. And they found the data. Okay. So, and they have understood that few underwent oxidation and few underwent reduction. They connected this to a ammeter or voltmeter. Okay. Voltmeter and found the EMF difference. Okay. And they have put into a table. The table is called as EMF series. Okay. What does EMF series or electrochemical series? Okay. In electrochemical series, what they have various metals and non-metals. Okay. Placed in the increasing order of their reduction potentials. That means like metals like lithium, tops, lithium, zinc, iron, there are many, aluminum, okay, tin, lead, etc. There are many metals which always underwent oxidation and acted as anode when they are combined with hydrogen gas electrode. There are metals like gold, silver, platinum, palladium, okay, our halides, Cl minus, F minus is at the bottom, okay. All these metals and non-metals always acted as cathodes when they are combined with hydrogen gas electrode. So in between, in the center, I took this hydrogen gas electrode, standard hydrogen gas electrode, She. Okay. And what I got? I've got a series. Okay. In this, I wanted to tell that these metals underwent oxidation and these metals underwent reduction. Okay. If these metals are undergoing reduction, I'll say it as reduction potential. These metals, I'll say it as oxidation potential. For convenience and ease, what I've done is that I've given only reduction potential for all the elements, whether it is metal or non-metal. Okay. But what I did to say that these metals underwent oxidation, I kept on giving minus signs. Okay. So whenever you see a minus sign before the value, it means that these acted as anodes with respect to hydrogen gas electrode. Okay. And followed by the reduction potentials of other metals and non-metals, which always acted as cathode, and it is called as electrochemical series. Okay, understood? So roll number 74. Good morning.
Good morning, ma'am.
Yeah. What's your name?
Ajay, madam.
Ajay. 74. Yeah, tell me, Ajay. So in hydrogen gas electrode, which is the metal?
Madam, I just lost my connection, madam, so that I cannot hear whole class.
You could not hear what it means by single electrode potential, boy.
In today's class, I didn't hear, madam. I lost my connection today. Frequently, I lost my connection.
Okay. So why did you join now?
From that time, I am joining, madam.
Okay.
3 to 4 times I have joined and lost my
No,
connection.
hope you check with your connectivity properly. You should be very careful. Okay?
Yes, ma'am. Yes,
I
ma'am.
think this is not the first STEM to say some excuse. Okay? Okay.
Yes,
next, roll number 88. Good morning.
Yes, ma'am. Good
Yeah,
morning.
tell me, in hydrogen gas electrode, which is the metal there?
Platinum, ma'am.
Platinum is the metal. Okay. What's the pressure of hydrogen gas?
1 atmosphere.
Okay. So the electrode potential is standard electrode potential or single electrode potential?
Standard.
Okay. What's the difference between standard and single electrode potentials?
When the temperature is 298 Kelvin and unit atmosphere,
Pressure.
it is
Or
standard
if it
electrode
is
potential.
electrolyte, what should be the concentration of electrolyte?
1 molar.
Molar, 1 molar, unit molar.
Okay. You got it now? Good. So I'll conclude what I was like trying to tell you all. So what I was trying to tell you all, ఏం చెప్పాను సరే ఏదో యానోడ్ ఏదో క్యాథోడ్, అది ఎప్పుడు యానోడో తెలియదు, ఎప్పుడు క్యాథోడో తెలియదు. సో అసలు ఏంటి అంటే ఏం చేసాం, సింపుల్ గా ఎలక్ట్రోడ్స్ ని కన్స్ట్రక్ట్ చేసుకుంటూ వెళ్ళిపోతాం. ఎలక్ట్రోడ్స్ ని ఎలా కన్స్ట్రక్ట్ చేస్తున్నారు, మెటల్ ని మెటల్ అయాన్ సొల్యూషన్ లో డిప్ చేస్తున్నారు. ఓకే, మనకి క్లారిటీ వచ్చేసింది ఏమని, దట్ వెన్ ఎ మెటల్ ఈస్ డిప్డ్ ఇన్ ఇట్స్ ఓన్ మెటల్ అయాన్ సొల్యూషన్, ఆ రెండింటి మధ్యలో ఉండే పొటెన్షియల్ డిఫరెన్స్ ని సింగిల్ ఎలక్ట్రోడ్ పొటెన్షియల్ కింద నేను మెజర్ చేస్తున్నాను అని చెప్పి. ఇంకోటి కూడా ఏం క్లారిటీ ఉంది, అన్ని మెటల్స్ కి ఒకటే టెండెన్సీ ఉండదు. ఒక మెటల్ ఒక మెటల్ అయాన్ సొల్యూషన్ లో డిప్ చేస్తే కొన్ని మెటల్స్ ఆక్సిడైజ్ అవుతాయి, లాస్ ఆఫ్ ఎలక్ట్రాన్స్ అవుతుంది, అప్పుడు అవి ఆక్సిడేషన్ పొటెన్షియల్స్ ఇస్తూ ఉంటాయి. కొన్ని మెటల్స్ కి ఏం టెండెన్సీ ఉంటుందంటే ఎలక్ట్రాన్స్ ఉంటే అవి తీసుకుని తొందరగా మెటల్ అయాన్ ఆటమ్ కింద కన్వర్ట్ అవ్వడానికి ప్రయత్నిస్తూ ఉంటుంది, అంటే రిడక్షన్ అవుతూ ఉంటుంది. సో అలాంటి కండిషన్స్ లో రిడక్షన్ పొటెన్షియల్స్ ఇస్తాయి. సో ఒక మెటల్ ఆక్సిడైజ్ అయినా రిడక్షన్ అయినా ఓకే, ఈ రెండు విషయాల్లో దానిని ఏమంటాను అంటే ఆ పొటెన్షియల్ డిఫరెన్స్ బిట్వీన్ మెటల్ అండ్ మెటల్ అయాన్ ఈస్ కాల్డ్ యాజ్ సింగిల్ ఎలక్ట్రోడ్ పొటెన్షియల్స్. దాని యూనిట్స్ వోల్ట్స్. సరే, అప్పుడు తర్వాత అవి స్టాండర్డ్ కండిషన్స్ లో మెజర్ చేస్తారు. ఎలా చేశారు స్టాండర్డ్ కండిషన్స్ అంటే, ప్రతిసారి 25 degrees సెంటిగ్రేడ్ దగ్గర 1 m కాన్సన్ట్రేషన్ ఆఫ్ ద ఎలక్ట్రోలైట్ తీసుకుని అది ఒక హైడ్రోజన్ గ్యాస్ ఎలక్ట్రోడ్ దేని ఈ స్టాండర్డ్ ఎలక్ట్రోడ్ పొటెన్షియల్ 0 కింద తీసుకున్న దానితో కంబైన్ చేసి ఒక పెద్ద చార్ట్ చేశారు ఎక్స్పెరిమెంట్స్ చేసి. ఓకే, ఆ చార్ట్ నే ఎలక్ట్రోకెమికల్ సిరీస్ అని చెప్పి అన్నారు. ఓకే, ఆ ఎలక్ట్రోకెమికల్ సిరీస్ లో ఏముంది, మెటల్స్ ని నాన్ మెటల్స్ ని వాటి సింగిల్ ఎలక్ట్రోడ్ పొటెన్షియల్స్ ఉన్నాయి. ఓకే, ఆ సింగిల్ ఎలక్ట్రోడ్ పొటెన్షియల్స్ మనకు తెలుసు అనుకో, అప్పుడు అర్థమైపోతుంది ఏది యానోడా ఏది క్యాథోడ్ అని చెప్పి అర్థమైపోతూ ఉంటుంది. సరే, ఆ ఎలక్ట్రోకెమికల్ సిరీస్ చార్ట్ పెట్టినప్పుడు మటుకు ఏం చేశారంటే, ఏవైతే యానోడ్ కింద యాక్ట్ చేశాయో హైడ్రోజన్ గ్యాస్ ఎలక్ట్రోడ్ తో నెగటివ్ సైన్ ఇచ్చి వాటి రిడక్షన్ పొటెన్షియల్స్ నే ఇచ్చారు. సో ఎలక్ట్రోకెమికల్ సిరీస్ ఆ చార్ట్ లో మనకు అన్ని రిడక్షన్ పొటెన్షియల్సే కనిపిస్తాయి. ఓకే, ఆక్సిడేషన్ పొటెన్షియల్స్ తీసేశారు కన్ఫ్యూజన్ ఉండకూడదని. సో ఎలక్ట్రోకెమికల్ సిరీస్ నువ్వు చూసావు అనుకో, ఎప్పుడూ నీకు రిడక్షన్ పొటెన్షియల్సే కనిపిస్తూ ఉంటాయి. సరే, ఆక్సిడేషన్ పొటెన్షియల్స్ ఉన్న వాటికి ఏం చేశారు, నెగటివ్ సైన్స్ ఇచ్చేసారు. అంటే ప్రతిసారి నేను ఎలక్ట్రోకెమికల్ సిరీస్ చూసినప్పుడు నెగటివ్ సైన్స్ ఉన్న మెటల్ అన్ని అర్థం ఏం చేసుకోగలను అంటే అవి ఆక్సిడైజ్ అయ్యి యానోడ్ కింద యాక్ట్ చేసాయి. ఓకే, దట్స్ వాట్. మధ్యలో ఏముంటుంది, షీ ఎలక్ట్రోడ్ ఉంటుంది, స్టాండర్డ్ హైడ్రోజన్ గ్యాస్ ఎలక్ట్రోడ్ హూస్ electrode potential, standard electrode potential is taken as 0. Okay, write the heading. Point number 25. Okay, point number 25 or 26?
25, ma'am.
25, right. Electrochemical series. Electrochemical series it is a chart or a table. It is a chart or a table containing the standard electrode potentials, containing the standard electrode potentials of various metals and non-metals, placed in the increasing order, of their standard reduction potentials. Placed in the increasing order of their standard reduction potentials. In brackets, SRP values. SRP values. Ante one of you were saying SRP value. What that SRP value means? Standard reduction potential. Okay. And what you should remember here is that which would act as anode and which would act as cathode is dependent on the single electrode potential, not on the ionizing tendencies. Ionization anedi ante enti? It is a tendency of a metal to take, or any material or any atom to take energy and lose its electron. So ikkada discussion entante not supplying energy. You're not supplying energy and forming ions. Okay, here the idea is seeing the spontaneity of a material. Like if I see you all when you come to college, I know as soon as the class is closed, oh my god, what a noise you would make. Just shut the books, just talk to your friends, and what spontaneity you would just relax till the next teacher comes. It's a spontaneous reaction. That's a behavioral pattern. These are things which are being studied by many of the psychologists actually, and they just give a report like that on the behavioral patterns of various things. Is it not spontaneous reaction that as soon as you come home, you'll throw your bag, you throw your things in your room, and just you want to relax, so quickly switch on TV, switch on all the gadgets of your interest, and just unlock your brain. But when you're in the class, you're very more conscious, you're disciplined, and you're under a gradient. Okay, so it's a behavioral pattern. That's a spontaneity of any individual. So when you're talking about a single electrode potentials, it shows the tendency. It's a spontaneous behavior of various metals and non-metals, either to lose electrons or gain electrons. So it's a spontaneous behavior that has been studied experimentally, and they have brought this table out. Okay, so understand what it means by the EMF series. That means they've placed various metals and non-metals in the increasing of order of their standard reduction potentials. Okay. And what did I tell you? In the center, they've put the hydrogen gas electrode, and they've placed all the metals on the top which underwent oxidation, and all the metals and non-metals which underwent reduction to the bottom. But they have made one clarity. What they did, those metals which underwent oxidation, they are represented by their oxidation potentials. But I'm giving the reduction potential, so I made a negative sign for them. Okay, so in Daniell cell, the right thing would be Zn/Zn plus 2 because it is oxidation. Now, if I were to write it as reduction, I'd write it as Zn plus 2/Zn with E minus value. Okay, here E is plus value. This is what is exactly happening. but this is oxidation potential. Now, if I were to write it for reduction potential, I'll put a minus sign, showing that it is reduction. That's I am showing. Okay. So every time in EMF series, what values I'll find? SRP values. Standard reduction potential values. And the units are volts. Okay. Easy. Right? Okay. So now what is your guess? Which would act as anode and which would act as cathode? Okay. Now turn back your pages. Okay. And yesterday I asked you about the cell reactions of various metal combinations. What did I give you yesterday? The first one. Hey, are you sleeping? Don't think
copper.
Zinc and silver.
class is not over yet.
Zinc and silver, nickel and copper, iron and zinc.
So shall I give you the SRP values now? Okay. So SRP value of zinc is minus 0.76 volts. SRP value of zinc is minus 0.76 volts. And that of silver is plus 0.8 volts. Plus 0.8 volts.
Anode zinc.
Okay. Which one is anode and which one is cathode?
Zinc anode, madam.
Zinc anode అంటున్నావు. ఎందుకు?
రిడక్షన్ పొటెన్షియల్ నెగటివ్ ఉంది కదా మేడం, అంటే అక్కడ ఆక్సిడేషన్ జరుగుతుంది.
Okay. Now, what you can conclude after seeing the SRP values? Roll number 89. Roll number 89 is present. Good morning. Okay. Roll number 97. Roll number 97 is present. I think they are angry because I have to say good afternoon. Roll number 90, you are present.
Yes, ma'am.
Good afternoon. Now tell me, so what is your guess? Which will act as anode and which will act as cathode?
Zinc and silver, ma'am.
Zinc and silver lo cheppu. Zinc SRP value enta minus 0.76.
Minus zinc ma'am anode.
Silver enta 0.8. సరే అయితే ఈ రెండు ఎస్ఆర్పి వాల్యూస్ ఇచ్చాను నీకు. నౌ వాట్ ఈస్ యువర్ గెస్?
జింక్ యానోడ్.
ఎందుకు? ఎందుకు నాన్న? కరెక్ట్ చెప్పావు. వాట్ ఈస్ యువర్ గెస్? నో ఇస్ ఎనీవన్ దేర్ టు గెస్ ద ఆన్సర్? You have already studied all these things, but this is a staunch recapitulation, I would say. Oxidation అవుతుంది. Okay.
Ma'am, zinc is anode.
Okay. ఏది రెడ్యూస్ అవుతుంది?
Silver.
సిల్వర్. ఎలా ఎందుకు అనుకుంటున్నావు అలాగా? ఎస్ఆర్పి వాల్యూస్ చూసి. ఓకే. సో దేని ఎస్ఆర్పి వాల్యూ మైనస్ ఉందో యాక్చువల్లీ అది హైడ్రోజన్ గ్యాస్ ఎలక్ట్రోడ్ తోనే అది యానోడ్ కింద యాక్ట్ చేసింది కాబట్టి ఇప్పుడు కూడా ఆబ్వియస్లీ 0.8 is greater than 0 కాబట్టి it is acting as anode, the other one is acting as cathode. Or can I make a thumb rule? Metals or non-metals with less SRP value will act as anode, and those electrodes which are having higher SRP value will always act as anode. Is the statement correct? Okay. And will you write it in a block? How can you guess the SRP values, whether a particular electrode is anode or cathode? What is your answer? Kids, what's the answer? What you should write it in a block? Point number 26. Okay. Electrodes with less SRP value will act as anode, and electrodes with more SRP value will act as cathode. Okay. Put 3 stars and write it in a block. Okay. What you will write? Electrode ante metal dipped in its own metal ion solution. So what you will write? Electrodes with less SRP value is equal to anode. Metal electrodes with more SRP value is equal to cathode. Right or wrong? Right. Did you write this? Imma, Rasara.
Yes, ma'am.
Now, what is the other combination I told you yesterday? What is the other combination? One was zinc and silver. You told me. What's the other combination I've asked you for?
Nickel and
Nickel and
copper.
copper.
Amma, Nana?
Nickel and copper.
Nickel and copper.
Nickel and copper. Now write. Nickel SRP value. See, ఇది రాసేటప్పుడు ఎలా రాయాలి? E naught డిడక్షన్ ఏ రాయాలి కదా ఎప్పుడు? Ni plus 2 / Ni is equal to minus 0.25 volt. Minus 0.25 volt. Whereas E naught of nickel and copper kada Cu2 plus / Cu is equal to plus 0.34 volt. Units trial eppudu. Which is anode and which is cathode?
Anode nickel.
Huh?
Nickel anode.
Copper is cathode.
Copper is cathode. Nickel is
Anode.
anode. Okay. Good. What's the next combination?
Zinc and iron.
Zinc and iron.
Zinc and iron. Oh. ఇది కొంచెం ఓకే రాయండి. జింక్ దిచ్చానా E naught. Okay. Zn plus 2 / Zn, that is SRP value I'm writing, reduction potential, minus 0.76 volts. Okay. Whereas E naught iron, Fe plus 2 / Fe is equal to minus 0.44 volts. Which is anode
Iron
and which
cathode.
is
Iron cathode, ma'am.
enti?
Iron cathode.
Iron cathode. Why?
Minus
Oh. So out of these two, zinc and iron, which will act as anode?
Zinc.
Zinc. And which will act as cathode? Iron.
Iron.
Easy. Now, within the series also, I can guess which is anode and which is cathode. Okay. And I'll conclude my session today. So I think I took 10 minutes more. It is fine because I'm just joining 10 minutes late. I'm allowing you to join 10 minutes late. I have a small question now. tell me the answer tomorrow or today. Right. Lithium has standard SRP value of, so E naught Li plus slash Li is equal to minus 3.05 volt. Minus 3.05 volt. Okay, right. When lithium electrode is taken, in which case it acts as cathode when it is combined with iron, zinc, silver, and nickel.
Less than minus 3.05.
Listen to me. When lithium electrode is combined with zinc, iron, nickel, and copper, in which case it will act as cathode is the question. Answer this after the attendance. Okay, answer your roll calls. Roll number 61 is present. 61. 61 is absent.
Present, ma'am. Present, ma'am. 62.